Okay, this is the review for the unit test coming up next week on parallel and perpendicular lines. You can go to page 32 of your packets if you're not there now. The unit test will consist of 20 questions for 55 points. On packet page 32 are all the theorems we talked about, whether I'm giving you parallel lines up here at the top, or if I want you to prove parallel lines down here at the bottom. What's not on here, and I want you to be familiar with, if you can look back in your notes from when we did it, was the auxiliary lines where the diagram may not be enough and I may need to add that extra parallel line in right between the two parallel lines that are given. So please make sure you go back and take a look at your notes on your own and just review the auxiliary line, because there may be a question tomorrow where you may have to add in your own auxiliary line. So again, packet page 32 covers all the theorems that we would put into our reasons column if we were doing a proof. Or what you can expect tomorrow too is if you're doing an algebra problem and I ask you to explain or justify, these would be your explanations here. On the next page are, right at the top, are the other parallel and perpendicular line theorem. Those are straight from your index cards we did this week. I can tell you that one of the two proofs that I'll be giving you tomorrow on the test will involve you using one of these theorems, maybe more than one. Okay, so make sure you're familiar with that. You are not allowed to have your index cards for the test, but again, you have them for studying purposes. There is quite a few questions on different equations of lines, writing equations of lines, graphing equations, graphing the lines given the equations. So you definitely want to know all the different forms we talked about on Wednesday in class. Make sure you can write your own equations, especially writing an equation of parallel and perpendicular lines. That's why you see I've added down here, making sure you guys review slopes of parallel and perpendicular lines. Remember, slope of a parallel line is the same slope, and slope of perpendicular lines are negative reciprocals. Okay. Constructions we went over on Thursday, how to construct a parallel line and how to construct a perpendicular line. And just remember, with a perpendicular line, the point I draw that perpendicular line through could be on the line or it could be off the line. Out of these two constructions, parallel lines and perpendicular lines, I will only be putting one on the test. Okay, so just make sure you're prepared for both. There may be some review questions coming up. If there is not, just grab a line, go grab an extra sheet of paper, put a line on there, put a point on there and say, okay, can I draw a line perpendicular through this point? Can I draw a line parallel through this point? On the next pages, before we go on to the review stuff, there will be two proofs, as I mentioned before. It's going to be 2 out of these 3 that I've given you. I could give you parallel lines in the givens. I could ask you to prove parallel lines, or, and I'm already telling you this because I told you a couple minutes ago, you will have to use your index card theorems for one of the proofs. Okay, you may have to use more theorems, but the index card theorems will come up on one of the 2 proofs I'm asking you to do, and those proofs are going to be 5 points apiece. Okay. What I would like to do here with you first is a couple proofs. So if you go to proof number 1 in the review, you can pause the video if you need time to get it set up. I'm just going to keep going right now. So if you need extra time, just pause the video, get back to it when you are all set up. Okay. So we have a pair of perpendicular lines, BF and AD are perpendicular. You can put the right angle symbol in there if you need to. CE and AD are perpendicular. So I have right angles here and here. First thing I'm asked, this is a 2-part proof. First thing I'm asked, prove BF is parallel to CE. All right, well, I'm not even going to look at the right angles. I'm just going to look strictly at the givens. If you see BF, tell me something about BF. It's perpendicular to AD. Tell me something about CE. Well, it's perpendicular to AD. And we know from our index card theorems that if 2 lines, BF and CE, are perpendicular to the same line, AD, they must be parallel to each other. So 2 lines perpendicular to the same line are parallel to each other. That's the quick way to do it. A little bit longer way to do it would have been telling me that these are right angles, perpendicular lines form right angles. They're congruent, all right angles are congruent, and then telling me the lines are parallel because you have congruent corresponding angles. Congruent corresponding angles. So that's the long way around it. I'm sure most of you would like to just finish it off in 2 steps. Okay, there's a second part now, and that is the show angle PFB, which is this angle right here, is congruent to QCE, this angle right here. Well, you see that both of them are on the parallel lines BF and CE. We just proved parallel in the first part. Okay, now can you identify what special types of angles that they are? Because if you see, yes, half of them are on the parallel lines, and you see the other half right here is on PFCQ. They're on the same transversal. They share a transversal. So those 2 angles are special types of angles. Think about it. See what type of angles you think they are, because they're more than the right angles. So I just can't say right angles are congruent. Okay. If you're noticing, they are outside the parallel lines. Okay. They're clearly outside the parallel lines. And now ask yourself, are they on the same side or alternate sides of the transversal? And you'll see that they are on alternate sides of the transversal. So alternate exterior angles we know are congruent if the lines are parallel. So that right away, that tells me PFB is congruent to QCE. Reason, my parallel lines, which were BF and CE, imply that alternate exterior angles are congruent. Okay. Is there alternative ways to get around that? Yes, there is, but I think the most direct way is the best way. Okay, so those ended up being alternate exterior angles, which if the lines are parallel, they are congruent. So there's the first proof done. I'll do the next one with you here. Actually, I'm going to do proof number 3 with you. So if you want to pause the video, get it set up, go right ahead. Okay, so I have CE parallel to AB, and I have CE bisects DCB, and I'm going to ask the same question I usually do in class. How many angles are getting cut in half? Only one. So this is not halves of equal quantities, right? But I could still use the fact that CE bisects DCB to say the following, that angle DCE is congruent to ECB. So let me get that jotted down before I forget. Angle DCE is congruent to angle ECB by definition of a bisector. Okay, so I have those angles congruent. And again, somehow I'm trying to get to A and B being congruent. Okay, well, I also see, based on the parallel lines, I see that angle ECB is congruent to angle B because they are parallel lines, and that implies that ECB and B are congruent because they are alternate interior angles. Okay, next up, because the proof statement does involve angle A, I should probably find something that's related to angle A. And I'm sticking with parallel lines AB and CE here to say angle A is going to be congruent to angle DCE, because if you take a look at those angles right now, those are corresponding angles, and we know parallel lines imply that corresponding angles are congruent. Now here is the dreaded substitution that you had on your quiz. If you take a look at the 3 of these statements right now, these 3 right here, pick 2 of them and you will never get A congruent to B. Okay, you pick 2 out of the 3, any combination you want, go ahead, I'll give you a minute, you will never get A congruent to B. So pick 2 right now. I'm going to pick statements 2 and 3. So in statements 2 and 3, I have DCE and ECB are equal, and I have ECB and angle B are equal. So from substitution, I can say DCE is congruent to angle B. One substitution. Now look at statement 4 and 5. Notice both angle A and angle B are congruent to DCE, which must mean by substitution, they're congruent to each other. So again, I needed 2 substitutions here, not just one. There is no way I could take statements 2, 3, and 4, take 2 of them at a time and get A congruent to B. All right. If you look through the remainder of your packet, you'll see more review questions and proofs. I've also given you some textbook questions that I recommend. Everything is in the back of that packet. All right. All your answers, all the answers will not be posted to Aspen. They're at the back of the packet. Okay. So just keep looking through the back of the packet, find the proof that matches up, find the textbook question that matches up. So go ahead and you can get started on your review questions.